All right, so we're starting with lesson 1.3.1 on linear regressions. Let's start off with this definition for correlation coefficient. So the correlation coefficient is represented by the variable r, okay? And here's the definition for it. It is a number between -1 and +1 calculated to determine the linear dependence of a set of data. Okay, and so you're probably wondering what this means. Let me write more first, and then I will show you some pictures. So over here, I want you to make a note that the closer r, remember r is the correlation coefficient, so we're using the letter r. The closer r is to -1 or 1, the more linear the data. I'm going to make another bullet point over here. I want you to say that if r is less than -0.7, so between -0.7 and -1, or r is greater than +0.7, so between 0.7 and 1. So if r is in those ranges, then the linear regression equation is a good fit. Okay? So let's take a look at some images to show you guys what this definition even means. Okay, so you can have a data set, and when you plot the data set, you will get some points on a graph. So if you have points on a graph that go straight downwards in this first box, when it is going downwards, it's decreasing, but it's perfectly straight, perfectly in a line, then your r is -1. Okay, so if it's perfectly straight, then you have -1. And then in the second one, in the second graph image, for those data points, you can see that it's mostly straight in a line, but it's a little bit off, right? So then you can see the r value is pretty close to -1, so the equation would still be a good fit. And then if you go to the third graph, you can see that this cluster of points just doesn't really fit into a line. It's more like a blob. So you can see the r value is not close to -1 at all. It's not close to 1 at all. It's more like close to 0. So if your correlation coefficient is closer to 0, such as in image C, where the r value is 0.08, if that number is closer to 0, then you have a picture that looks like this. It's not really linear. Okay? If you look at image D, you can see that the dots form a straight line, but this time it's increasing. So since it's increasing, then you have a +1 as your correlation coefficient. And then for E, you can see positive 0.86, pretty close to 1, but not exactly. And you can see how those points kind of look like they would form a straight line, but it's not exact. And finally, for graph F, those points are definitely not in a straight line, and so it has an r value of 0. Okay, so the r is the correlation coefficient, and this correlation coefficient tells you how well does your data fit into a straight line. Okay, so that's what the correlation coefficient tells you, and this is represented by the letter r. Okay, so Now we're going to go on to numbers 1 and 2 as our example problems. In the directions, it says, determine the linear regression equation and correlation coefficient for each data set. Circle whether the linear regression equation is appropriate for the data set. Round your answer to the nearest whole number. Okay, so number 1, the table shows the attendance for the varsity football game at Pedro's High School. So on game 1, there was 2,000 people in attendance. In game 2, there's 2,132, and so on and so forth. I'm not going to read all of them. And then we need to get the linear regression equation out of this, and we're going to do this all on Desmos.com. So let's go over to Desmos. And you guys have already probably seen the video, so I'm just going to follow that, add a table here. And I believe it was 1, 2, 3, 4, 5, 6. Okay. Let's go over here. It says 2,000. Oops. Oops. Okay, there we go. And what? 2132. 2198. Just enter your numbers in. 2301. 2285. 2401. Oops. Okay, so at this point, you might want to take a look and see what your dots even look like. So I'm just going to zoom out. Remember, we need to see the 2000s. Okay, so as you can see, they're just kind of like in a blob over there. That's because even though I can see the 2000s on my y-axis, my x-axis, I don't need to see 0 to 2000 on my x-axis. I only need to see like 1 through 6. So let me take a look on how to fix that. Do you see settings right over there where the pop-up just came out? So on our x-axis, we don't want it to be from negative 774 all the way to 2,327. We just need it to go from, let's do negative 1 all the way to 7. Okay. Okay, so I just clicked out of it, and then now you can see our graph. And then from here, we can sorry, I'm lagging a little bit. Give me one moment. All right, so we're going to add an expression, and then we're going to type y with a, what's it called? Underscore. We need to look for the underscore on this keyboard. You guys know where your underscore is on your keyboard, right? I'm not sure I can type it on my iPad, which I did not anticipate. Oh, okay. So on my iPad, I could press it over here next to the 1, 2, 3, this button. Okay. But you can see on the link that you watched earlier that on the computer, you can type y_1 to get this. Okay, now I'm going to continue typing what the website told me to type. So we use a little squiggly, and then I'm going to write M, X, and then I want the little one again. And then Where's my, there, plus, so many things to stare at, plus b. There we go, okay. So once you type that in, you can see that Desmos gave us a straight line through our graph. And then you could see our equation on the bottom. It tells us M should be 73.34. I'm gonna write that down on a scratch paper. And then it tells us our B is 1962.8. Okay. And then it tells us our R value is 0.9694. So I just wrote all of those down except for the R squared. We don't really need to look at the R squared, okay? So writing those down, now let's go back to our worksheet. So our linear regression equation, it's y equals mx plus b. So I'm gonna write y equals, the m value that they told us is 73.34. Let me point it out to you again. Remember the m value they gave us right over here is 73.34. Rounding it to the nearest whole number, like our instructions said, this would be just 73. 73x plus, and then we need our b value. What was our b value? According to Desmos, our b value was 1962.8. Rounding that to the nearest whole number, we're going to get 1963. Okay? So remember, it just wanted us to round our answer to the nearest whole number, so that's why I'm doing that. So here is our linear regression equation. The R value, I'm not going to go back because it looks like it lags when I do that, but our R value was 0.97. I'm going to round it to the nearest hundredth. Okay, and so we have an R value that is really, really close to 1. You can also see in our picture, that lags quite a bit. Okay, in the picture, we can see our dots, and we can see that straight line, and we can see that our dots are pretty close to that straight line. So both the R value and our visual shows us that this is a pretty good fit. So we're going to circle good fit for the data. I'm going to circle that. I'm going to highlight that instead. There you go. Good fit for the data. It just looks better when I highlight it. Okay. So then, when we're going over here, it says predict the attendance for game 9. So look how it says f of 9. That means we need to plug in the number 9 into our equation. So I'm going to show you what I mean by that. So in our y equals 73x plus 1963, I'm going to write 73 instead of x, 9 plus 1963. And then we're going to PEMDAS this. So multiply first. 73 times 9, I'm going to use a calculator. 73 times 9, 657 plus 1963. And then we can add 2,620. We can estimate that if the trend continues in this manner, there will be 2,620 people in attendance on game 9. So in the 9th game, we predict 2,620 people will attend. Okay? So at this point, if you have any questions, just pause the video and call me over. Otherwise, keep watching. Okay, so number 2, the table shows the attendance for the annual spring concert at Eva's High School for 6 years. We have 2007 represented by the number 0. We have attendance on the right side. So there's 3 columns here, but in Desmos, you can only enter 2 columns. So let me highlight the columns you want to put into delta into Desmos. You're going to put this one as your x value, and you're going to put this one as your y value. So you're going to ignore the 2000s in the years, okay? Ignore the 2007 through 2012. You are going to enter in this yellow part, okay? So let's take a look at, or actually, I'm going to let you guys do this part on your own. Enter it into Desmos.com, see if you guys can get the answer, and then we'll come back after you've done that. So pause the video. All right, so while you guys pause it, I went ahead and put those numbers into Desmos as well. And so let's take a look at the results together. So over here, I kept the same scaling of my graph over here, so you can see it's still zoomed in or zoomed out quite a bit. I'm going to adjust the scale so that we can take a better look at the y values. Our y values, our range on this data ranges from 773 as the smallest all the way to 902. So I'm going to maybe want to see maybe from 700 to 950. So over here on the y-axis, let's take a look from, oh wait, no, let's do negative 100 all the way to 1000. Okay. I mean, as long as you can see all the points, it really doesn't matter. Like you could have it rotated or zoomed in, zoomed out, it's fine. So here we can see our dots better and we can see the purple line going straight through it. It does look like our blue dots are pretty close to our purple line. So let's see, will our R value match it? Okay, so our R value is 0.88. Well, 0.8 repeating, so I'm going to write 0.89. I'm going to round it. We also have an M value of 25.17, round it to 25. We have a B value of 771.2, round it, so 771. Okay, let's go back and put it in our equation, which hopefully you got a chance to write already. Your equation should come out to this. And your R value, we already just read it straight off. It was 0.89. So remember, put it in y equals mx plus b format. So 25x plus 771. Okay, and since our blue dots were close to our purple line, and since our R value is pretty close to 1, we have a good fit for the data. Now it says predict the attendance in 2017, and it says we're plugging in 10. Why do you think we're plugging in 10? I want you to just think about that for a little bit. I'll give you some time. Okay, so I want you to think 2007 is year 0, where 0 represents the year 2007, 1 represents 2008, 2 represents 2009, 3 represents 2010, 4 represents 2011, 5 represents 2012. If we go up to 2013, that should be 6. 2014, that should be 7. 2018, that should be 8. Wait, how did I jump that? 2015 should be 8. 2016 should be 9. And so therefore 2017 should be 10. So the number we are plugging in to our equation is 10. So y is equal to 25x plus 771. 25x is 10 plus 771. Multiplying through PEMDAS, 25 times 10 is 250. And then adding it together, 771 plus 250, we get 1021. So if the trend follows, then in 2017, there should have been 1,021 people. So we predict 1,021 people will attend the annual spring concert when in 2017. Okay, so put it in a full sentence. So hopefully you got this answer for number 2, and if not, it's totally fine. Remember, we're still learning. Yeah, so make sure you ask questions if you have any, because I noticed on the last test, quite a few people were trying to ask me questions during the test. And that's not how school works. You gotta ask questions before the test. Otherwise, I can't help you during the test. I mean, the test is a test. So make sure you ask your questions now when you have them, okay?